Okay, this is just a short video about your Yamaha p22. This is an excellent era of Yamaha, made in Thompson, Georgia, sought after. So Yamaha's a high tension instrument, and it is also mostly wooden action. There's one plastic part, the jack is plastic. High tension is good because when a piano is high tension, that means that seasonally it will go sharp or flat, but still sound good with itself. A lower tension instrument, when it's a little out of tune, it's all the way out of tune. Some of the time I'm going to talk with my hands, so I'm flying blind a little here. The soundboard of a piano is a crown. On an upright, it's like a belly pushing out. On a grand, it's like an arched ceiling. And it's designed to be at a very specific curvature under the down-bearing force of the string. This piano, when it's in tune, is probably holding 14 tons of pressure on the wire. So there's tug of war along the wire and there's down-bearing force. So we're talking about 14 tons. It's cumulative tension throughout. So when a piano hasn't been tuned in a long time or when it's been moved, the crown of the soundboard is settling under the down-bearing change. So if you have a piano that hasn't been tuned in 10 years, the force of the wire pushing down on the curved soundboard is insufficient, and it sits at an exaggerated posture, and as we tune it, it forces back down to the correct geometry. That's happened a little here, especially in the bass section, because it was the furthest out. It just means that it needs a couple weeks to settle. Yamaha's a very stable, very well weatherized instrument, so I don't expect any issues with that. The piano, however, could use some regulation improvements. The touch response mechanism of the piano is basically a miniature catapult. You're shooting the hammer at the string and catching and reloading it. You need to be out of the way or there's no room for the string to ring. So all the dynamic range, all of our control as a musician comes from combinations of soft to loud, which translates to how far are you when you start from the string and how close to the string do you get when you fire the catapult. We're discussing this as distance, which is inaccurate but easy. Accurately, it's discussed as timing, but we're just going to look at it as distance. So this is a 440, and I'm pushing down on it in slow motion. I'm not trying to strike the string, but I am going to demonstrate how far away from the string that hammer is when I stop having influence. That's massive. For a Yamaha, it wants to be 1 millimeter. This is 14 millimeters. So what does that mean? It means that when the musician tries to play softly, it's hard for the piano hammer to travel that great distance with a small amount of energy. It also means for the tuner, so when I'm tuning, I need to knock it into tune so that 100 soft strikes don't destabilize it. So the first piece of the wire, I move the tuning pin. The first piece of the wire to move is between the tuning pin and this pressure plate. And then there's the speaking length, which is what we hear. So imagine if I was stretching a rubber band over my hand. Be a lot of stretch rubber band here and not a lot of stretch rubber band after the direction change. So I'm using maximum force to the wire to draw out any latent motion onto the speaking length. The same thing's happening here on the steel. However, since we've got early let-off, not only is it hard for the musician to play softly, it's hard for the technician to hit really hard. And that the description of that is you're trying to karate chop through a piece of wood, but you stop putting energy halfway to it. So more pudding than punch arrives. So both sides of the dynamic of this piano can be improved. Touch response on the light end for the musician and touch response on the hard end, which they will enjoy as well, but I really need it in order to stabilize. Early let-off is the most common misadjustment that I see on the piano. And 99% of the time when someone gets early let-off, they've had another audible symptom that has been misunderstood. So usually that is a bobbling hammer, and I did hear some of that. A bobbling hammer is when the hammer strikes the string, rebounds off that plastic component I was showing you, the jack. That's the firing pin of our miniature catapult. So the hammer hits the string, rebounds off the jack, which hasn't turned out of the way enough, and double strikes on the string. It sounds like gutta-ga-dung, gutta-ga-dung. It's usually worse on a soft strike, worse with the sustained pedal down. So when we correct early let-off, oftentimes we find the bobbling hammer. We find the underlying symptom that was misunderstood and misadjusted. And we got to get rid of that as well. So things that I notice on the piano. we probably have low key height. So all of the motion on the piano is determined by the key. Everything in the action is timing. Everything on the key is distance. The key determines all of the movement. If you don't push down the key, nothing else changes. So you could imagine if you're trying to roll a ball down a hill, the ball is going to roll much more intensely on a steep hill. So I believe, just by my eye, I haven't measured anything, but by my eye, and I worked at the Yamaha dealer, so I know these pianos pretty well. I feel like I'm seeing too much of the balance rail pin. How much too much? Well, maybe the thickness of a piece of cardboard that would be used to make a cereal box. Very thin but substantial. I mean, you can change the piano with a shim the width of a piece of paper. So that thin cardboard's pretty substantial. But I believe our key height is too low. And so it's making the intensity of all the corresponding action parts sluggish. We may not need to change that, but my eye says it's there. When we correct the let off, we'll probably end up having to increase key depth. So key depth means that more jack rotation. So the misunderstanding that's been applied is, well, let's fire our catapult earlier so we don't encounter this symptom that's at the end of the hammer strike, the bobbling hammer. But what we want to have is the jack turn more. We don't want to have it turn earlier. The problem is still there. It's just now after let off. And we're paying this dynamic price for it of not being able to play softly. So I want to correct the let off. And then I want to get rid of whatever underlying symptom led to the incorrect let off. Chances are there's a third tier adjustment, which has to do with your damper spring tension. When you've got early let off, all that extra force that you're playing that doesn't go to the hammer to the string goes somewhere. Well, it ends up going to the damper mechanism, and you can inadvertently really over strengthen your damper return springs. The damper silence the wire. They need to have force, but they don't need to have resistance. And you can feel it on this keyboard where you start getting motion and then you pick up friction. That's your damper return springs. So there's probably a couple tiers of change to make. Correct the let off. Get a little bit more key depth so that the jack rotation clears and we don't have that bobble. And then if we still have a bobble, it's from over-strengthened damper springs pushing the action parts backwards, so pushing the whipping into retrograde. So the jack's back underneath, giving us the same audible symptom. If we get through all three of those and the piano is still bobbling, then it's our key height. We're just not getting intensity of motion. And my eye does say that the keys are too shallow. All of this is elective, but all of it's really going to be noticeable to the musician, and we could make sample notes. The process is you do some white notes, high end, mid range, low end. You do some black notes, high end, mid range. You make sure everybody agrees. It's this much change to let off. It's this much change to height. It's this much change to tension. And then we apply that. So we do a little sample section first to see if we like it. There's an order of operations. Before I was describing the latent motion on the wire. So if I corrected your let off today and was able to deliver maximum force to the wire, we're going to lose this tuning because any unaddressed latent motion above the pressure plate will make its way into the speaking leg. So what we want to do is change all those dynamics before a tuning and then have all that extra force available to settle the tuning. We also have a damp chaser system. Those are excellent. It's not plugged in. I'm not plugging it in today because it takes at least 3 weeks to acclimatize the wood, and I want to just have this prepared for the services that you're doing. Yamaha's very stable, and in all likelihood, you could get away with not plugging in your humidity control system until next autumn. But let's see how the piano does. Today was a substantial change. You might need a second tuning anyway. If we decide to do the let-off adjustment, all those changes can be timed toward the same final tuning. So if this tuning needs to settle from the move, we got another 2 months of the piano finding the floor, settle from the tension change over the crown of the soundboard. We could correspond that with the change of getting the humidity level back correctly, and then right before the final tuning, do all those let-off changes. Please call me if you have any questions or concerns. It's great to meet you.